Okay, I'm going to cover 4 questions from that packet of 111 balancing equations. These are going to be 30, 31, 32, and 33. I'll start with the first 2 here, just to give you some pointers about how to approach different problems as they come about. One thing to notice that a lot of the issues that most people have, balancing oxygens at the end, or balancing oxygens at all, in all of these equations, 31, 32, 33, and 34, there is a ton of oxygen. So we're going to hold off on all oxygens until the very last part of each equation. So to start, we're going to pick something that looks pretty apparent in both. Something that looks pretty apparent on both sides of the equation as unbalanced. I see that hydrogens here are 3. Hydrogens over here are split between 2 different molecules, so we're going to hold off on that as well. The only other option, because we're holding off oxygen to the end, is phosphorus. So I'm going to start by balancing my phosphorus by putting a 2 here. That now makes 2 phosphorus, and over here I already had 2. Now we count our hydrogens. 2 times 3 is 6. And over here we have 4 and 2, so those make 6. Sorry, my pen doesn't go to the top of my screen. Now we count our oxygens. This is a 7 and a 1, so we have 8. And by putting the 2 in front, that also makes 8 oxygens. So that one looked tougher when I first started. I haven't done these yet, so I'm totally winging this just to be clear. So that one wasn't as tough as I originally suspected it would be. Turned out to be pretty easy. Only need to put a 2. When you record these online, you're going to put 1s, so the computer recognizes that there's a number there, and it is in fact a 1. If you leave it blank, it will count it wrong. The computer won't recognize it otherwise. So here, next problem, number 31. We have carbon, oxygen, nitrogen, hydrogen. Oxygens, again, are spread out all over the place. So again, we're going to hold off to the end. First, we're going to look at other things that need to be balanced. We have hydrogens. There's 4 there, plus 2, so 6 hydrogens. Nitrogen, we have 1 here. We have 2 here. And carbon has 1 and 1. So the carbons are good right now. So let's balance out our nitrogens. We have 2 nitrogens here. So I'm going to put a 2, which makes 2 nitrogens, and our 2 nitrogens. Carbon is still balanced, 1 and 1, so we'll leave that alone. We didn't mess with hydrogen over here, which makes it 6. And if I look over here, that is 4, plus 2 is 6. My oxygens, I have 2 here. And I have an oxygen here and an oxygen here, so I have a 2 there as well, which means this one also balanced with a 2. A 1, a 1, and a 1. And that one's pretty good. Yeah, I think we're good there. So let's go to the next page. Next page is, these are a little more difficult looking. What we have here are compounds that have a lot of polyatomic ions, and oftentimes when people see parentheses, it makes them freak out. Makes them second guess themselves a lot because they try to count all parts of a polyatomic ion, like SO4. They try to count an S and 4 O's. You shouldn't do that because if you notice on both sides, here and here, SO4 isn't changed. So in this equation, this 4 and the 1 that's kind of next to the sulfur, they're hot numbers. They don't get touched on either side of this equation, so you don't have to worry about separating it into sulfur and oxygen. It's just sulfate. So let's start on the top one, number 32. It's aluminum hydroxide and sulfuric acid to make aluminum sulfate and water. We're going to leave our SO4s as one thing. SO4s are one type of thing, so we're not going to separate them into sulfur and oxygen. Right here, I have 3 SO4s. Over here, I have 1. So I need 3 over here, so I'm going to multiply this whole thing by 3 to make it now 3 SO4s. That affects my hydrogens to a 6 here, but I also have 3 here, so that's going to be a problem. So let's look at other things that we can do and hold off for a second on things that are split. So hydrogens split, oxygens are split all over the place, so do those last. We still have aluminum here that needs to be balanced with a 2. So I'll come over here and I'll put a 2 here, which now makes 2 aluminums. 2 aluminums. And now everything is balanced except for the 2 things, the hydrogens and the oxygens that are split up everywhere. So let's count oxygens over here. This is 3 times 2. So I have 6. And I'm not going to count this oxygen because that's already balanced. We balanced our sulfate. That oxygen doesn't count towards total oxygen. So we have 6 over here. Here I only have 1. So I need to put a 6 there to make it 6. Now our hydrogens over here, we have 12. And over here, we have 3 times 2, 6. My board doesn't work up there. And 3 times 2 is 6, so we're at 12 again. So this one here would be a 2, a 3, a 1, and a 6 to balance it. So leaving the sulfate alone kind of helped at the beginning to get through everything else. The second one here, number 33. Sulfate doesn't change on either side. OH doesn't change on either side. So we're going to not separate them. We're going to say that's SO4 and the other one's OH. They don't change. So we treat them as one thing. So here I have 3 SO4s. Here I have 1. I have to multiply that by 3 to make 3. Sulfate is now balanced. By putting a 3 in front of the K2, it also makes 6 for the Ks, or potassium. So over here, to balance out my potassium, I have to put a 6. So I have 6. My hydroxides, because I put the 6 here, I now have 6 hydroxides. Over here, I only have 3, so I need to multiply this by 2. 2 times 3, 6 hydroxides. And my irons, 2. Over here it's already a 2. So that is now balanced. 2 irons, 3 sulfates, 3 sulfates, 6 potassiums, 6 potassiums, 6 hydroxides, 6 hydroxides. And we are done with a 1, a 6, a 3, and a 2. Hope that helps. You can leave comments somewhere on my page or on the Google Classroom if you have other issues or things that are really taking some time to balance, and I will try to address them. Good luck. Keep at it. Have a good day.